Professor Krishna Reddy from University of Illinois, Chicago. He is a distinguished researcher and the director of Geotechnical and Geoenvironmental Engineering Laboratory and Sustainable Engineering Research Laboratory at University of Illinois, Chicago. And I know Professor Reddy since 2008, I think. I had just started my career. I thought I was young back then. He was young, but he was a star back then. And he was the chair of the Geoenvironmental Engineering Committee of American Society of Civil Engineers. And it's now 16 years later. I am getting old, and he looks younger. So every year we receive emails with his accomplishments of the year. It looks bigger than everybody else's CV, including myself. So you think it's just his CV is just that one single year. So he's done a lot of work in a lot of different fields, including a lot of geoenvironmental engineering and environmental geotechnology research. It's my pleasure to invite Professor Reddy to the podium. With no further ado, the floor is yours.
So good morning. Good morning. It's working. Okay. Yeah. Okay. So good morning, everyone. Thanks for attending this conference. As I mentioned during my opening session, this is a very unique conference where we learn not only the technical stuff, but we make professional connections. So I'm going to talk about a topic that you may or may not be familiar. It's called biochar. I am from University of Illinois, Chicago. I work on different areas, even though I'm talking about biochar. My areas of research are environmental remediation of soil, sediments, groundwater, and stormwater. I also work on waste management and landfill engineering. I work on life cycle assessment, sustainability and resiliency, and I also work on geotechnical engineering. So I work on a lot of different topics, but I wanted to choose a topic that is more relevant and for research that's going on these days. So you can find more information about my research on these websites. First of all, let me ask audience, how many of you know what is biochar? Can you raise your hand? So just to see very few hands up. So hopefully by the time I finish my presentation, you will understand what biochar is. So what I'm going to do now in this presentation is I'm going to explain what is biochar. And then I'm going to say biochar as is not always enough. So you need to engineer it or modify it. I'm going to explain why we need to do that one. What are the ways that we can modify the biochar to meet the requirements? And then I'm going to show you there are many applications in many engineering fields, even in geotechnical engineering, and I'm going to focus more on geoenvironmental applications. And then, there are a lot of research challenges and a lot of opportunities. There is a lot of scope to do research on this topic, so I will point out those things at the end, and I will close with some closing comments. What is biochar? So there is no universally accepted definition of biochar. There are some agencies like International Biochar Initiative, it has a definition. US Biochar Initiative has its definition. European Biochar Certificate has its definition. And International Union of Pure and Applied Chemistry has a definition. US Department of Agriculture has a definition. Biochar International, this is one organization that has a definition. And then Institute of Food and Agriculture, University of Florida has its own definition. So there are definitions, many definitions given by different agencies. But you don't have to get confused with all those definitions. You should know this common definition. What is common definition of biochar is? Biochar is nothing but a carbonaceous material, basically carbon material, that is produced from thermal decomposition of organic matter in the absence of limited or no oxygen presence, okay, in the absence of or limited supply of oxygen. So basically, it's created from thermal process of organic matter in the absence of oxygen. So that's a kind of a basic definition. If you can remember, that's fine. And biochar has been receiving tremendous interest of researchers, tremendous amount of research. So this graph is really mind-blowing. For example, look at it. So how many publications have been published? You can see how the evolution of publications. Those bar charts are the number of publications published in a year. It's not cumulative. Cumulative is that line, you see it. Look at how many publications last year. Close to 7,000. Before that, 6,000. Before that, 5,000. So if you look at 2013, there are not many publications. But if you add up all the publications as of now, you have about 37,000 publications. So this is really, a lot of people are doing research on this one. So you really need to know what is this that is attracting the attention of a lot of researchers, right? So you don't want to be left behind. So hopefully my presentation can help you understand what biochar is, and maybe you can pursue some research on this one. As I said, biochar is basically produced from biomass. So biomass could be anything, as you see here. And then basically you are feeding into this thermal heating unit called pyrolysis. And in this one, you heat it up to some certain temperature without letting any oxygen in. And when you do that one, you're going to get this biofuel, syngas and pyrolysis. So this has been going on. So basically, this is the way you produce the alternative energy, right? So a lot of people who work in the energy area, they work on this one because they're converting, organic waste into energy. But as a byproduct, you get this material called biochar. Biochar is similar to charcoal. So as I said, pyrolysis is basically you are heating up that organic matter at temperature ranging from 300 to 800 degrees centigrade. But depending upon how you are doing pyrolysis, it can be classified into two types of pyrolysis. Slow pyrolysis is where you slowly increase the temperature to the highest desired temperature. It could take several hours. That's called slow pyrolysis. The fast pyrolysis is you don't wait it, just heat up the temperature to the desired value and heat it up the biomass. So that is called fast pyrolysis. So that takes only a few minutes. This is hours. And these are the pyrolysis units. You can get lab scale, mobile scale, very large unit. So which is nice. If you want to create a biochar at your project site, you can do it. So you can, you don't have to have a huge plant like this one. So you can have a mobile plant and then you can do the project wherever you want. But the pyrolysis conditions, if you look at the literature, it varies a lot. The temperature could vary from 100 to 1,000, residence time 1 to 10 hours, heating rate 1 to 20 degrees centigrade per minute. So there are many studies. You look at it, I kind of try to consolidate all that information there. And there are other biochar production methods other than pyrolysis. One is called gasification, other one called hydrothermal carbonation, other one called torrefaction. So you need to remember there could be other than pyrolysis process to produce the biochar. So biochar is produced from biomass. Biomass is basically organic waste. Look at all these types of organic mass. So banana peels, like all these things. You can have chicken litter or pig litter. Sludges. You can see all kinds of stuff that rice husk, all the organic waste that you have, that can be converted into biochar. So biochar is made from organic waste. In terms of waste management, organic waste is very difficult to get rid of it. So here you can use the organic waste to produce the biofuels, bioenergy, and also the biochar. So just I'm giving you some idea about the different types of biochar. All this information is in my paper that is going to be published in this conference proceedings. So there are different types of wood-based organic waste. Then you have different types of plant-based organic waste. Right here, you can see it. And you could be animal-based organic waste. You can see this one. And you could have other waste like a sewage sludge, municipal solid waste, all these organic waste. Any type of organic waste that you have that can be used as a biomass or feedstock for creating the biochar. And in terms of the quantities of the organic waste we generate, it's a lot of it. So, agriculture waste, for example, so we create 1,000 million tons per year. So that keeps on accumulating if you don't do anything. And municipal solid waste, is 2,000 million tons per year, but out of that municipal solid waste, more than 40% is the organic mass. So you have organic fraction. So all this can be converted into biofuel and bioenergy. So biochar, when it is produced, it will look differently depending upon how you subject the pyrolysis process. So this is the kind of pictures of different types of biochar when you produce it. Biochar has a very unique properties. Right? What are these unique properties? For example, chemical properties. It has a high surface functional groups. They play a major role when you are doing some, using this material for treatment purposes. And you have a high cation exchange capacity, favorable mineral content, high carbon content, conducive to oxidation, and it has an alkaline pH. And it has unique physical properties, high heat capacity, high water holding capacity, highly porous structure, which is very important. And it has stable structure. It does not degrade. Or the biochar is going to last for a long time. And then it has high surface area. These are very unique physical and chemical properties that you can exploit for various applications. Now, there are many different applications. You can use as a soil amendment for different purposes I listed there. And you can use for greenhouse gas emissions control. So there are many applications there I mentioned. And for contamination removal, water, air, soil, wastewater, you can use this material for. And you can use as a construction material also in this one. And you can use, not only in the civil engineering field, people are using in electrical and chemical applications. So many applications for this material that is made from biomass, it's organic waste. And if you look at a big picture of the implications, the biochar use can contribute significantly to sustainable development goals. So I listed a few of them, 6, 7, 13, 12, 11, 9 as examples. So you can see, this has huge implications even in a sustainable development point of view. Okay, so that's about biochar very briefly. So I hope you understood what biochar is. Now, biochar is not always has the properties that you need it for your specific application. Let's say, you are working on some project and you need a material, but the biochar does not have the properties that you want. Why? Because, this has a limited contamination range. Let's say if I'm dealing with wastewater or industrial water or contaminated soil, I have a contaminants, maybe this material is not good as it is, as a biochar. Limited absorption capacities, limited anionic capacity, high ash content, impurities, high volatile content, low density, small particle size, low active sites, harder to separate from aqueous media, high dependence on properties of biochar on the preparation conditions and feedstock. So those are the problems. But you cannot be discouraged by those problems. If those problems are not favorable to you, you can modify them. That's called engineered biochar. So you can modify the biochar in different ways. So here you have a biomass, and you do the pyrolysis process, as I said, these different processes, and then you produce the biochar. And then this biochar does not have properties that you want. So you need modifications. So this is the post-treatment modifications. There are different types of modifications, physical, chemical, biological, magnetic, and you can create composites. And then when you do that one, you get an engineered biochar or modified biochar, okay? And this can be done in a different ways. You can treat the biomass and then subject it to, you have a modified biomass, and then subject it to pyrolysis, then you can also get a modified biochar. So which route you take it, the treatment is a post-treatment or pre-treatment. You can do either way. And then you have these different options to do that. Now, so in the physical treatment, if I want to do the physical treatment, there are different ways to do the treatment. If I want to do the chemical treatment, there are different ways to do it. If I want to do the biological treatment, different ways to do it. Magnetic modifications, you can do it. And you can combine this biochar with other materials, and then you can create a biochar composite, right? And in my paper, I provide all these details, so don't worry about not losing this information. Now, the treatment that you have to do is it has to give the improvement that you are looking for, right? Biochar, as it is doesn't have properties, but you are looking for some improved properties. And you need to tailor the treatment to get the improvement that you want. For example, among the physical, so you can have just a ball milling. Basically, you can reduce the size. People create the nano biochar, and it has high surface area, and it has unique properties to serve certain functions that is based on the nano size. So like that, if you look at the chemical, for example, if I use this kind of a modification, I can get a high surface area. And then, I can use the biological process, and you can, activate it with the microbes, and you can get, bioactive biochar. And you can use the composites. You can, add biochar with any of these materials, including clays. For example, we are working on with the composite biochar, chitosan composite, that can really give very unique characteristics to the biochar that can help us in our applications. Okay? So now, let me summarize what I said. Biomass type. What are the different types of biomass? Based on the literature that we found, there are more than 70 types of biochar, the biomass types people have used to create the biochar. Now, what are the different ways to produce the biochar? There are 4 different ways to produce the biochar, right? And then in the production method, you have variables. What is the highest heating temperature? What is the residence time? What is the heating rate? The combinations of those can result 1,890 combinations. And then modifications. So after you make the biochar, if it is not good enough, then you have to do the pre-treatment. You can do the physical, chemical, biological, magnetic, or post-treatment. You can do that one. That combination is 30%. So let's say permutation combinations. How many types of biochars you can have? So 70 times 4 times 1890 times 31, that leads to 16 million types of biochar. 16 million types of biochar, right? So the point that I want to mention is when you are looking at the literature, whenever you are looking at the publications on biochar, be mindful about what is the feedstock, how it is produced, what are its characteristics. You may be talking about different material, so that's why in the literature, everybody uses in the title biochar, but out of 16 million, which one you are talking about, right? So this is the important point to remember. And this biochar can be used in different types of applications. For example, contamination remediation, as a soil amendment, as a bioenergy, as a climate change, waste management, and as a construction material, geomaterials. So many different applications, so many different applications. So just, after my presentation, think about, you are doing some research, you can ask yourself, can I use biochar in my research? Okay? If you want to discuss with me later on, I will be very glad to discuss that one. And then it's unique, because if I work on contamination remediation, so look at that. When you modify the biochar, you get these unique properties, and that can take out different types of contaminants I'm showing you here. So for environmental remediation applications, the modified biochar is the best that you can think about. So we do a lot of research on biochar at UIC. For a long time, we have been doing for last maybe at least 15, 20 years. So these are the kind of projects that we worked on. We used as a filter media for stormwater treatment, biocover for enhanced landfill methane oxidation, and we used to stabilize the heavy metals in contaminated soils, and we used as an organic amendment in phytoremediation projects, and we have a project that's going on right now. We are creating a biochar chitosan or biochar chitosan and bentonite composites for barrier applications. And you can use for, just even geotechnical purposes. If you want to interested in improving the mechanical strength, you can use this one too. So one thing that I want to mention is a lot of studies just deal with lab scale studies. But you really need to go out to the field and try to see what you found in the lab is applicable or not. when you are doing the full-scale applications, you need to look at what is my source of biochar is. Because a lot of people make biochar in the lab using the lab scale reactor, 100 grams, 200 grams, and they do the research on that one. But when you are doing out in the field, you need tons of material. So where you can get the tons of material, you really need to match it, right? You have to look at the material that is going to be available for field applications. And I love doing the field work. That's the pictures of me working at a landfill site with my students. So there are a lot of information on my previous projects. So just the challenges, okay? It's a very confusing. Hopefully you understood what I meant by. There are no standards for producing the biochar. Everybody is creating their own biochar in different ways. So as I said, like you're creating one of the 16 million biochars. Which biochar you're producing? There is no standards. There are no standards for applications of biochar. Okay, I want to use for wastewater treatment, but there are no standards on how to use biochar for that applications. Inconsistent or contradictory research studies. You get frustrated when you review the literature on biochar. One study says this, other study says this. And it is possible because you are dealing with totally different material, right? So that's a really huge problem when you are doing the literature review. Don't let your students ignore things that you don't like it, because if somebody says it doesn't work, you can understand why it doesn't work, but that particular biochar may not be useful. So not all biochars are the same, there are variable properties. And biochar modification, if you modify a biochar for one particular application, same thing is not applicable for other applications. So the modification has to be focused on the application that you are dealing with. And you don't expect that modification to work for other applications. And the problem is with biochar, a lot of studies are lab scale studies, not many field scale studies. So you really need to focus on field scale studies and what are the issues that are learned by doing the field scale studies. And then, is the use of biochar economical? People argue that, hey, I'm using the organic mass, it's cheap. Not necessarily. So you really need to worry whether it is truly economical or not, because it depends upon the biomass sourcing, and where are you making the biochar? What is the transportation distances involved in that? What are the other logistical issues involved in that? So the cost not necessarily always cheap. Okay, so you have to keep in mind. And the other question is it sustainable? People say that, using the biochar is a sustainable option. Not necessarily. You really need to, depends upon the specific purpose, method, and application. You really have to quantify the sustainability and see that it is indeed sustainable from the point of view of broader environmental impacts, economic impacts, and social impacts. So you really need to quantify, because just using biochar is a sustainable material is not true. Now that's the challenges, but the opportunities. I like the opportunities a lot. That's why the challenges, you should try to overcome those. First of all, you are converting organic mass into renewable energy source. Who doesn't like that, right? Otherwise, garbage is going to be all over. You're converting organic waste into renewable energy source. You know that any alternative source to fossil fuels is the great thing these days from the climate change point of view. And this supports the circular economy. You are converting the waste into beneficial use, and so it's a better solid waste management. And then you are doing the carbon sequestration and addressing the climate change mitigation. As I said, there are many applications, but I work in geoenvironmental engineering field, and I can see many applications in geoenvironmental engineering field for waste containment, contaminant remediation, soil quality enhancement. And you feel good about doing the research on this one because you are contributing to broader good of sustainability. And the last point I want to mention is opportunities outweigh challenges. The challenges should not be discouraging to you because the opportunities are really much greater, but you should focus on the research not for limited lab scale, but take them into applications. Just the last slide in the closing comments, just the takeaway points from all my presentation is this. The biochar production and applications provide multiple benefits, including energy production, circular economy, and sustainable development goals. Biochar offer potential solutions to many engineering challenges, particularly in geoenvironmental engineering. You can achieve desired properties of biochar by selecting appropriate modification techniques. And you can achieve sustainability benefits provided you are careful about how you use it, in which applications you use it. You need to do the assessment and make sure that it is right. And the biggest concern, is that we don't have standards for production, properties, and applications. So hopefully they are going to come up very soon. So the biochar does, it does not say anything about soil, but biochar and soil combinations are plenty. The geotechnical engineers, the geoenvironmental engineers, and civil engineers in general can benefit by using the biochar in combination with the materials that people deal with. So I want to thank Professor Koda again for organizing this conference. And I want to thank my graduate student who helped me to put this presentation together. And we have an ongoing research project funded by National Science Foundation. I want to acknowledge their funding help. So thank you so much for listening to me.